Hello everyone, welcome to our lecture on OpenCV. So in this lecture we will be seeing about the practical implementation of OpenCV using Python. We can broadly divide this practical implementation of OpenCV into two parts. In the first part we will be seeing about the processing of image with the OpenCV, whereas in the second part we will be moving on to the application of OpenCV where we will be seeing the face detection with OpenCV. So first of all, let us move on to the processing of image using OpenCV. So for the processing of an image, first the most required thing is we have to upload all the required files into the Google Colab so that we can be using them for our implementation. For the loading of images or uploading of the images, we will be using google.colab. So and in that we have a function called as upload. So upload function helps us to upload all the required files, which helps us to store them in that particular session. The most important point that we have to note right here is, so all the files that will be uploaded by using this upload function will be stayed only in that particular session, and once the session is closed all the files will be automatically deleted. So first of all, let us run this code and start our implementation. So we can see that, so first of all we will be getting connected to the environment. So let us wait for a couple of seconds so that we will be connecting to the environment, and we'll be initializing the resources. All our resources will be initialized. Okay, so we got connected so that our code execution got started. First of all, we have to choose all the required files from our local system. So we have to press on this button of choose files. So I am choosing the three image files, so by the name CV Collab 3, CV Lab 2 and faces. I am uploading all of them into my Google Colab environment. So you can see that all the files will be uploaded one by one. So the time of upload will depend upon the speed of your internet. So once the file uploading is done, all these will be temporarily stored in your environment. And once you shut down the Google Colab, all the files will be automatically deleted. So in the previous lecture, while we are dealing with pandas, we had also seen how we have to upload the files to the Google Drive so that we can permanently use them and access them while we are running the code. So this is the another way of uploading the files into the Google Colab so that we can use them during our practical implementation. So now once the files are uploaded, let us move to the loading of image. So how can we load the image? So the loading of the image will be done using OpenCV. So first of all, I am importing the module called as CV2. So you might be confused. So what is this CV2 also? So initially we had actually worked on installation of OpenCV while we are covering the theoretical concepts of OpenCV. So there we had discussed that the command for installing the OpenCV is pip install python OpenCV. Right here we are importing the module called as CV2. So right here while importing we will be using import CV2. Okay, so but during the installation process we will be using python OpenCV. Once we import this module, we will be using the function called as imread. So imread function will help us to read the image file. So I am passing the image file called as cvlab2. So we will be using the same names as that of the name what we had given the files before uploading them from our local system. So I am using the same name and I am reading it. I am storing it into the img variable. So I am running this code. So once I run this code, all this image will be read and it will be stored into img. We have to find out what actually is present in img. Does image is directly present in img? So in which format it is stored? So let us try to understand what actually is present in the image. So first of all, let us try to print what exactly is present in the variable img. So I am printing img. So let us see what is being printed. You can see something in the form of array is printed. Is this a list? Is this an array? What is it? So let us check it. Can we find anything or so? We can't find anything. So let me type something like print of type of img. So let me put the before one in the comment and let me run this code. So let us check what is the type of img variable. So what we got is img is being stored in the form of a numpy array. So our image is being stored in the form of numpy array. Okay, so now let us see what exactly is present in that. So let us try to analyze what is exactly is present in the numpy array. For that I am using the function called as shape. So we had already discussed earlier that numpy array dot shape will give us the shape of that particular numpy array. So if I run this code, you will be seeing the shape of numpy array as 720, 1280, 3. So if you observe keenly, all the images what we use for our regularly daily purpose, so most of them are in the format of RGB. So we had already previously discussed there are various kinds of formats around us, something like RGB, BGR, grayscale also. So most of the image what we use are RGB, in the form of RGB. So we can notice right here that the shape of this is 720, 1280, 3. So what does this 3 represent? 3 represent the last stage of the numpy array is consisting of 3 values. That is, we can clearly notice that our image is consisting of 3 bands, that is red, green and blue. So that is how the image is being stored in the numpy array. So this is one of the most important point, right? Because once we understand how the image is being stored, then only we will be able to understand how we can do pre-processing work over that particular image. So if we move further, so we could just got representing the image in the form of numpy array. We are able to print that particular numpy array, but we are not seeing what actually the image is. Okay, so before moving on to the coding part where we see how the image looks like, let me show you what are all the images I have uploaded. So I had actually uploaded the 3 images. The first one is CV Lab 2. So this is the particular image, and let me show you the second image. This is the second image what I had uploaded. This is CV Collab 3, and here is the third image what I have uploaded. This image we will be using it for the purpose of our example of recognizing faces. So if we move back into the coding part, let us try to actually print the image in the form of an image, rather than it being printed in the form of a numpy array. So first of all, for that I will be using the matplotlib. So previously, while discussing about the matplotlib, we had seen now matplotlib can also be used to display the images. So we will be just using the matplotlib. I am importing the matplotlib.pyplot as plt, and I am using the imshow function. As we had discussed earlier, imshow will be used to display the image. In that I am passing our img, or actually image. Okay, so I am using plt.show. Okay, so I am running this code. So once I run this code, you got the image looking something like this. So is this the actual image what we have uploaded? Let me show you back the actual image what we had uploaded. Let us keep both of them side by side. So this is actually the image what we had uploaded. So but the image is looking something like this. Why this had happened? So while we are discussing about the theoretical concepts of OpenCV, while we are discussing about the images, how the images will look like, I had already mentioned that there are various libraries in Python, and each and every library understands the image in its own format. So right here, actually our OpenCV will understand the image in the form of BGR. So whatever image we give, OpenCV will store it in the form of BGR. But our matplotlib will store the image in the form of, or else it will understand the image in the form of RGB format. So we are passing our same image and we are getting it displayed in the different format. So that is the reason why we got the image being displayed differently. For example, if we move back into the original image, you can see something like almost this red color is being displayed something like a violet color. So this is because the difference between the color formats of OpenCV and matplotlib. So what we have to do is, before we pass our image from OpenCV into the matplotlib, that is we had read the image from the OpenCV. So before passing that image into the matplotlib, we have to actually convert that BGR image into the RGB format. For that we will be using a function called as CVT color. Okay, so CVT color is also the function which is present in the OpenCV. So we had actually previously imported the CV2, so we'll be using CV2 dot cvt color, and for that we'll be passing the first argument as img, this is our actual image, and we'll be passing the second argument as cv2 dot color underscore bgr to rgb. So we'll be changing our bgr format into rgb format, and then we'll be displaying the image using imshow. So let me run this code. So if we run this code, we'll be getting the output something like this, which is actually our original image. So this is how the color bands will vary from one library of Python to another library of Python. So this is the most important thing what we have to remember. We generally will find it difficult while we are working on with a very lengthy amounts of code, where we forget to convert from one format to another format, which will rise in the very drastic amount of errors while we are working with our real-time projects also. So this is one of the very important thing what we have to keep in mind. So now let us move on to the part where we will look into some making modifications in our image also. So let us take our image. So let us take the image cv2 collab3.jpg, and I am reading it using the function called as imread. So for time's sake, I am keeping it everything in the comment. And first of all, what I am doing is I am actually trying to make modification in the pixel which is actually present in the value of 0 0. So if you take this as a graph, you can see the image which is present in 0 0. Okay, so this is 0 and this is 0. So image which is pixel which is present right here, I am making it modification something like this. I am changing it to 220, 0, 0. Okay, so and let me try to print it out. Let us check what will be present right there. So you can see nothing difference it from the original image also. So if you see the original image, this is our original image and this is the modified thing. So you can see nothing much difference. This is because, so as I had told you earlier, pixel is considered to be the smallest element which is present in the image. So though we make some modifications in a single pixel, we can't find it much difference. So I am using a for loop, a couple of for loops actually, to iterate over the large amount of pixels and make modifications in them. So I am taking the horizontal range of 100 to 500 and a vertical range of 100 to 600 pixels, and I am making modifications in those pixel values. So if I run this code, we will be having output something like this. All the pixels which are present in this particular range are being modified to 0 0 0. That is, they are all the pixels that are present in this particular area are being modified to the color of black, because 0 0 0 will represent the black color obviously. So that is how we can make modifications in a particular image. If we move further, so we can see some interesting stuff like drawing a rectangle box for a particular image. So you may be thinking, so why does we need a rectangle box? So we need a rectangle box, we need some text on the particular image, we need some circles, we need an ellipse. Likewise, we might need all these shapes and all this text to be displayed on a particular image based upon the requirement of the application. So these are all considered to be one of the most important things while we are dealing with the OpenCV. You should be understanding it carefully. Okay, so first of all, I am just loading this particular image also. So now I am using a function called as cv2.rectangle. Okay, so what does this function do is, so this will construct the rectangle based upon the coordinate points what we give. Okay, and this has the arguments like the first one argument is img. So this img will be corresponding to our actual image. So the next thing is starting point, the third thing is ending point, from where our rectangle should start, and from to where the rectangle should end. And then we'll be having the argument called as color. So what should be the color of the rectangle box what we'll be drawing, and the next thing is thickness. Okay, so these are all the things what we should be passing while we are dealing with our rectangle function of OpenCV. Okay, so I have initialized all these values of image start point, end point also. So like I had loaded the image, given the starting point value, given the ending point value, given the color, given the thickness. Okay, I have given all these things. Okay, so now what I am doing is I am just running this code. So you can see the image is being displayed like this. So, and this is our actual rectangle box what we had drawn. For example, if you want to draw the box around this particular face also, what we have to do is we have to just modify the starting point and ending point values. For example, I am making modifications to the starting point values, and we have to get the ending point to a bit down also. So for that, what I am making is, so we shouldn't make modifications in the x coordinate values because x coordinate values are fine. Okay, so we have to modify the y coordinate values. So instead of giving the y coordinate values of 400 for the starting point, I will make it 100. Okay, so and for the ending point, instead of making it to 600, so we'll be changing it to something like 900 or so. Okay, so let me run this code and let us check it out. So yeah, we can see almost we got it perfect. So maybe we can reduce some x coordinate values for the ending point, because our ending point is this. We can make put it here. Okay, so if we just want face, so for this what we will be doing is I'm giving it to something like 1700 or so to make it look a little perfect. Okay, this seems to be better. So this is how we can construct the rectangle based upon our requirement around the object what is required. So it might be face, it might be a pencil, it might be a pen, it might be something, whatever it might be, you can be able to construct the rectangle or the given object using this OpenCV on a particular image. So this is one of the very important application what we'll be generally using while we are doing some object detection tasks on images using our machine learning models also. So these are all the applications, or else these are all the processing steps what we will be doing while we are doing that machine learning task. Okay, so if we move much further, we can even add text to that particular image. This is rather more simple. There is no need to give two coordinate values. Just we have to give something like org. So this is actually the starting point of the text. Okay, so and we will be using the function called as put text. Okay, so this is our actual function called as put text. So what does this put text function do is, the put text function will help us to place the text on our particular image. So right here, so the arguments for this are img. So img will be corresponding to our actual image, then text, the text what we have to be placing. So I am already initializing all these values before. Okay, so and we got org. What does this org represent? Org will represent a tuple which will be consisting of the starting point x coordinate and y coordinate values of the particular text where we want to place. For example, we want to place the text here, so we should be giving the x coordinate and y coordinate values of this particular point. Okay, so that is how org represent. Then the font of the text. Okay, there are various fonts available based upon your requirement, and you can give the font. And what does this font scale is? So font scale will be just giving you something like a size of the particular text what you will be facing. So but the font scale will vary from one font to another font. That is, it is not actually similar to that of size of the text. Based upon the type of the font scale will vary. So you should make sure that which particular scale of the font matches your requirement of your font. Okay, so these are all the things what you have to remember while you are placing the text. Some other arguments like thickness, which represent the thickness of the text, and then there are some arguments called as line arguments, and there are some arguments which will help you to place the data of the image from top to bottom or bottom to false. But these are all the optional arguments. Okay, so all the arguments like the image what we have to pass, second one is the text what we have to pass, the starting point, the font, and the font scale, and the color. So these are all the most important and mandatory arguments that we have to pass into a put function. Okay, so let me run this code and show you how it works. So this is how it will be working. So I have given the text as hello right here. So you can see the hello is being displayed. So this is how our put text function will be working to place the text over a particular image also. So in the next step, we will be seeing about the pre-processing part of a particular image. So pre-processing is quite simple. So these are some operations like making some modifications in the size of the image, making some modifications in rotation of the image, finding some edges or so. Likewise, these are all more simple, but these are considered to be more important while we are doing pre-processing stuff for training all our machine learning models, while we are working on object detection tasks also. Okay, so the function is also quite simple. The function is cv2.resize. Okay, first of all we are reading the image, then we are using the function called as resize. Okay, resize function will be having the two arguments. The first argument will be corresponding to the image actually. So the second argument will be corresponding to our actual coordinate values. That is, the second argument will be corresponding to the size of the actual image also. So after that we will be using the convert color function, and that will be displaying the image. Okay, so if we run this, so this is the actual image after resizing. So you can see this is the original image. We got the size of more than 2000 horizontally and more than 1400 vertically, but you can see the size is being reduced to 350 400 by using the resize function. Why do we need the resize function? So because resize function helps us to resize all the images. For example, you got a data set consisting of all the various kinds of images, also consisting of images of various shapes and sizes. If you want to modify it and make them to a unique size, so we will be using this resize function to make them all to a regularly same size also. So this is how we will be resizing the image. The next thing is we will be rotating an image. So this is also quite simple. There are various kinds of rotations available: clockwise rotation, anti-clockwise rotation, and we can be able to rotate it through 180 degrees or so. Likewise, so and the function what we'll be using for the rotation is cv2.rotate. Okay, so this function will help us to rotate an image by 180 degrees or 90 degrees clockwise or 90 degrees counterclockwise. So the first argument for this is our actual image what we will be loading, and the second argument for this is rotation. Okay, so what rotation we want, either it is 180 or 90. So if we run this code, you will be seeing the image is being rotated through 180 degrees. Okay, so and if you see, this is our original image. Okay, and here is the image that is being rotated 180 degrees. So this is how rotation function will work to rotate a particular image. So now you will be stricken by a question. So why does we need the rotation? So the rotation will also work with the similar stuff of pre-processing the data set. So we will be generally rotating our images to create larger sizes of data set. So we will be generally rotating the images to make our model better trainable, so that it will be getting better predictions also. While you are working with the model, you can get a clear understanding over this. Okay, later on if we move much further, so the most important thing is edge detection. So why I call edge detection the most important thing is, edge detection will help us to find the edges present in a particular image also. Why does we need the edges? So edges are considered to be the actual insights which are present in a particular image. Okay, so this is how edge detection can be done. So we'll be using a function called as cv2.canny. So what does this function do? So this function will be helpful to detect the edges present in a particular image also. So I am just running this particular code so that we will be able to get the edges. Okay, so this is how edge detection will be done, and this is our actual image also. Okay, once we are done with the edge detection, now let us move on to some very important part of our actual application of OpenCV, that is the face detection using OpenCV. So how can we detect faces with OpenCV? So OpenCV is just a library which will be consisting of some pre-processing stuff with the images also. How can we do that? So OpenCV also got some pre-trained models, pre-trained machine learning models which help us to detect the images. There is nothing much for you to collect the data set, to train on the data set also. Just we have to load the model, we have to give the image to that particular model, it will work by itself. Okay, there is no need to do any much pre-processing and all the stuff. Okay, so for that what I will be using is, so there is a model called as Haar Cascade Classifier. So I'll be just using this cascade classifier of OpenCV. The model is present in this particular directory of cv2.data.har_cascades, and the model will be present in the form of a XML file. Okay, so there are various kinds of models actually available. So there are some models which will be able to detect faces, this will be able to detect mouth, or which will be able to detect ears, or else likewise. So I'm just using the particular model which will help us to detect just only face. Okay, our model can't detect eyes, our model can't detect nose or ears or whatever it might be. Just will be detecting the faces present in the particular image. Okay, so just I am loading this particular model also and storing it into face cascade variable. Okay, so what is this face cascade? So face cascade is an instance of our face cascade classifier model. Okay, so this is the most important thing what we have to remember. We are creating the instance for our model right here. Once we are done with creating the instance for our model, I'm loading our actual image. Okay, so as I had shown you earlier, so the image what I am loading is, this is our actual image what I am loading. So I'm trying to detect faces of all the people present right here. Okay, so I'm loading this image. I'm converting the image from our actual format to grayscale. Okay, so after that what I'll be doing is, I'll be using our face cascade classifier, and I'll be using the function which is related to this face cascade called as detect multiscale. Okay, so in this what we have to pass is, we have to pass a grayscale image into it. So once you pass the grayscale image into it, so you'll be getting the instance of faces. Okay, so the instance of faces is nothing but a numpy array which will be consisting of the faces, all the faces that are present. After that what we will be doing is, we will be drawing the rectangle faces on that particular image. For that we will be actually now using the thing what we had learnt earlier, that is how to draw the rectangle over a particular image. And I'll be iterating our variables x, y, w, h, where I'm taking these 4 variables, I'm iterating it over the faces array, and I'm trying to draw the rectangle. Okay, so this is how I am drawing the rectangle over all the faces. Once my drawing of rectangle is done, I will be just displaying this particular image. Okay, so you can see this is our particular image also. So if you see further, why we got one numpy array is, right here I had printed this our image. Okay, let me put it in the comment and let me print it our actual image as an image. Okay, so this is how we can detect the faces of all the persons present in a particular image by using OpenCV. Okay, so this is what our present lecture is. So in the next lecture we will be discussing about more advanced concepts related to Python. So before that I have a small exercise for you. So the task for you is, try to develop a small code which will help you to capture the image by using the camera or webcam of your particular device, and try to detect the faces from that particular device also. So this is the task that I am assigning to you. Try to complete it by the time you move into the next lecture. Thank you guys, that's it for present lecture. Let us meet in the next lecture.